Welcome to iTTV for Form 4 Chemistry. We start with the first chapter today, Introduction to Chemistry. In this chapter, we're going to look at two things. What are the jobs related to chemistry? And then after that, we want to look at the scientific method involved when we do chemistry and chemistry investigations. What is chemistry? Chemistry is the study of the structure of matter and interaction of matter. Examples of common chemicals used in daily life are salt and vinegar enhances the taste of food. Marble is used in the construction of buildings. Occupations involving chemistry: doctors, biochemists, nutritionist, forensic scientist, pharmacist, chemical engineers, agriculturalist, biotechnologist, food technologist, polymer scientist, genetic scientist. So there is a wide variety of careers that you can choose from if you focus and specialize in chemistry. Chemical-based industries: plastics, petroleum and natural gas, pharmaceutical, manufacturing. And these are just but a few of the industries that involve chemistry. Scientific investigation, scientific skills, scientific methods, scientific attitudes, and noble values. So this component, which is scientific investigation, is broken into these three categories. The scientific skills you need in the laboratory, the scientific method you use when doing an investigation, and finally, the attitude and noble values you apply when doing your experiments. Scientific skill consists of science process skills, manipulative skills. What are science process skills? Scientific method of investigation used by scientists to study a particular phenomena or investigate a particular situation. Systematic steps in a scientific method: making observation to identify a research problem, making an inference, forming a hypothesis, identifying the variables, controlling the variables, planning the investigation procedures, collecting data, analyzing and interpreting data, making conclusion, writing report. You need to know the steps in the scientific method. It's a common question in examinations, but more important, you really need to know the steps because you, the scientists, are going to be doing these investigations. So you need to know the procedure you have to follow in order to do a correct, accurate, and useful investigation. Making observation. Observe to identify the research problem. What is the question to be answered through the investigation or research? Making an inference. Conclusion based on preliminary observations. Hypothesis. A general statement that states the correlation between the manipulated variable and the responding variable. This hypothesis can be tested by the investigation research. Variables should be identified before starting an investigation. Is controlled during the investigation. Three types of variables. 1. Manipulated variable. Variable that is deliberately changed to find out its effect on the responding variable. 2. Responding variable. Factor that changes due to the change in the manipulated variable. Controlled variable. Factors that are fixed so that the effects recorded is due to the manipulated variable. Planning the investigation procedures. 1. Prepare the materials and apparatus. 2. State the steps taken during the investigation. 3. Determine the method used to collect the data. 4. State how the data is to be analyzed and presented. Collecting data. Making observations, taking readings or measurements, and recording these systematically. Displaying the data in the form of a table or a graph. Analyzing and interpreting the data collected. Comparing the data based on certain criteria and explaining it rationally. Calculating the results. Interpreting the results from the graph. Making a conclusion. To decide whether the hypothesis should be accepted or rejected. Experiment. Observation. The reaction between 2 spoons of calcium carbonate and hydrochloric acid produces a bigger volume of carbon dioxide gas. So, this is what we see. We are in a lab and we see that when 2 spoonfuls of calcium carbonate is used, you get more carbon dioxide gas. So this is the observation. Now, based on this observation, there is a problem that we are going to face. So if we go back to the slide, there is a problem statement. How does the amount of calcium carbonate affect the volume of carbon dioxide produced with a constant volume of hydrochloric acid? So this is the problem you get. You've seen something and then you think to yourself, right, how does this affect this? How does the amount of calcium carbonate affect the amount of carbon dioxide produced when you have a fixed volume of hydrochloric acid which has got a fixed concentration at the same time? So that's your observation and that's your problem statement. Now the next thing that you should be doing is to come up with some sort of hypothesis based on what you are thinking about. Planning the investigation. Diagram. It's quite important that you have a diagram to show you how the apparatus is going to be put together. Hypothesis. The bigger the mass of calcium carbonate, the higher the volume of carbon dioxide produced. So this is your hypothesis. This is what you think or you believe you're going to see in the experiment. Materials and apparatus. Calcium carbonate, burette, delivery tube, retort stand, water trough, HCl acid, 2 mole, spatula, measuring cylinder, filter paper, wooden block. So we've got all of this in front of me, the calcium carbonate, the hydrochloric acid, the delivery tube, the water trough, a burette that's already prepared. And now think about a few other things we need. If you look at the diagram, there's obviously a conical flask that is necessary. So we have a conical flask over here in which the reaction will take place. Now, you need to take the calcium carbonate from here and get it into there. So we've got a spoon here. We need to make sure the amount of calcium carbonate is correct. So we've got a little wooden block here that I will show you how I'm going to use later to try and make sure the amount used is a constant. We've got some filter paper. I'll explain how we're going to use this in a moment. And we have a measuring cylinder to measure out the correct volume of acid that we're going to use. So these are your apparatus and materials. Very important that you know all of these and list them out. Variables. Manipulated variable, amount of calcium carbonate. Responding variable, volume of carbon dioxide gas collected. Controlled variable, concentration and volume of hydrochloric acid. Action to be taken: manipulated variable. Repeat experiment by 2 spoons of calcium carbonate. So what we mean here is, in the first experiment, use 1 spoon. In the second experiment, use 2 spoons. So you are changing the manipulated variable. Responding variable. Measure the volume of gas collected. So, in the first experiment, we measure how much gas we're going to collect. Then, in the second experiment, we repeat and measure the amount of gas collected. And then we can compare the change that has occurred. Controlled variable. Repeat the experiment by using the same concentration and volume of hydrochloric acid. Meaning that in each case, I should use the same amount of hydrochloric acid and use the same hydrochloric acid throughout the experiment. Now that we've had a look at all of these things, let's do the experiment. We'll start by measuring out the hydrochloric acid. I'll just move this delivery tube. We're going to use just 10 centimeter cube of hydrochloric acid. So I'm going to measure this. So here I have 10 centimeter cube of hydrochloric acid, and I'm going to place this in a conical flask. So I take the acid, and I put it in the conical flask. Next, I'm going to get my calcium carbonate. We only want 1 spoonful, so we grab some. We take this block to wipe off the excess, so we have a nice even amount of calcium carbonate, which I will then place on this filter paper, like so. We get the delivery tube in place so that we're all ready, because the gas is going to come out quite quickly. So let's begin. Get the calcium carbonate, add it to the acid very quickly, put the bung on, and as you can see, we're collecting some gas here. Okay, so the gas has stopped coming out. We'll remove this, take the reading over here, which is roughly 32.2. So this reading needs to be noted down. So experiment 1, 32.2 centimeter cube is where the gas went to. We can calculate the volume later by subtracting 50 minus 32.2. Now we do the second experiment, where we use 2 spoonfuls. Now the acid, once again 10 centimeter cube. Pour the acid into the conical flask. Get the stopper. Get the stopper in place. And we are ready to add the calcium carbonate to the acid. And once again, we're getting the gas being produced. And it's almost stopping here. We're just getting a bit of gas coming out. Let's give it a bit of a shake to make sure the reaction is totally finished. The last bubble coming up here. Okay, we've got another bubble coming up. Okay, and that's pretty much... Oh, we got one more, one last bubble. Let's get it coming up. Okay, here it comes. And then after that, I think the reaction is stopped. Okay, and now we take our reading over here. And then basically we can compare the readings in both and see whether our hypothesis is correct. And the reading we get is 13.8 centimeters cube. So let's record this on the board. So in experiment 2, we collected 13.8 up to 13.8. So now we have the volume we collected in experiment 1. Sorry, I should put the 2 in there. In experiment 1 and in experiment 2. From here we can calculate the actual volume. So the actual volume in each one is just a little bit of math. So let's make a line here and make a note. We want to know the actual volume. Now this part, the actual volume, will come in the tabulation of data. Tabulation of data. Experiment 1, experiment 2. Amount of calcium carbonate, spoon, 1 spoon, 2 spoon. So when you tabulate your data, what you need to do is to create a table whereby the first column or the column in the front needs to give you your manipulated variable. The second column, the one behind, should give you your responding variable. So in our case, if we were to do our tabulation of data, this is experiment 1 and experiment 2. Our manipulated variable was the amount of calcium carbonate that we used, and we used the measurements of spoons. So here we write the amount of calcium carbonate. I'm just going to use the symbols for calcium carbonate here, which is CaCO3, and we used spoon. So in the experiment 1 we used 1 spoon, in experiment 2 we used 2 spoons. Now the second column that you're going to create here, this needs to show the responding variable, which is the amount of gas that actually was produced in each experiment. Now in this case, what we have is an initial volume, a final volume, and then the actual volume that we're going to use. But for simplicity's sake, we're just going to put down the actual volume. The actual volume can be calculated by, if we do the first one up here, 50 minus 32.2, which equals 17.8 centimeter cube. For the second experiment, the actual volume would be 50 minus 13.8, which equals 36.2 centimeter cube. So these are our actual volumes that we've used in the experiment. Now, tabulation of data. In tabulation of data, the first column is where we write the manipulated variable, and the second column, the responding variable. So let's do a table for our results. So we draw a table over here. Here we have experiment 1 and experiment 2. Let's put in the key information. The first part up here, what we want to put in is the amount of calcium carbonate that we used. So let's write that in here. Amount of CaCO3. And what we used was a spoon. So let's put that in there, spoon. So this is the first column. Then we have a second column. The second column, this was our responding variable. Here is the volume. Volume of CO2. Here we used centimeter cube. So let's finish off this table like so. The amount of calcium carbonate that we used was 1 spoonful, 2 spoonfuls. The volume of gas that we collected in experiment 1 was 17.8, and in experiment 2, 36.2, which is roughly almost exactly double what we got in the first experiment, which is what we expected to see. 1 spoonful gave us 17.8, 2 spoonfuls gave us almost double the value. Conclusion: the amount of calcium carbonate is doubled. The volume of carbon dioxide produced is doubled. Now that you've done the experiment, gone through all the steps, you are able to write up your report. Make sure that all the steps are clearly identified. Please, these are things that you must remember: noble values and good moral values. Don't change your results. If your results were wrong, you need to redo the experiment. Don't copy from someone else. Make sure that everything you write in your report comes from your own experiment. That's all the time we have for this lesson in chemistry. Thank you for watching iTTV.